For the introduction, biomass energy play a key role in the global renewable energy transition by providing a reliable and dispatchable alternative to fossil fuel that complement variable sources such as wind and solar power. Denmark is a global leader in this area, integrating high-efficiency biomass system to supply low-carbon electricity and district heating in line with its climate hard target for deep emission reduction and climate neutrality by 2045. Everdorf Power Station in Haverdorf exemplifies this transition, having evolved from a coal-fired plant into one of the world's most efficient biomass-based combustion heat and power facilities, supplying electricity and district heating to the greater Copenhagen area. However, growing concern over biomass sustainability and carbon emission have shifted focus toward advanced carbon management solution, leading to the integration of bioenergy with carbon capture and storage (BECCS) to transform Everdorf from a carbon-neutral plant into a carbon-negative energy hub. Next, we move to the Denmark background, which is the biomass use and shift toward BECCS. Biomass fuel are classified as carbon neutral in national accounting. Responsible, resource and diverse major biomass fuel include imported sustainable wood pellet, local agriculture residents such as straw, diversified fuel mix, reduce supply risk, utilize domestic agriculture waste. Denmark is now shifting towards carbon negative solution. BECCS is being integrated into major bioenergy plant. Full operation expected by early 2026. Built on Denmark's mature biomass infrastructure. Next, we move to the Denmark background, Denmark energy and biomass background. Denmark aims to achieve climate neutrality by 2045. Strong nation policies drive a transition away from fossil fuel. Biomass play a key role in the high-efficiency CHP plants, large-scale district heating network. Biomass support the grid stability and provide base load power, complement variable renewables such as wind and solar. Facilitate like Everdorf achieve up to 94% fuel utilization through waste heat recovery.
Hi, my name is Muhammad Afizin bin Saleh and I will be explaining about my part in the slide. Okay, for my slide the first slide is about the identified problem at Everdorf Power Station. Okay, Everdorf Power Station is one of the most efficient biomass-based CHP plant in the world. However, even though biomass is considered carbon neutral, burning large amount of biomass still release significant carbon dioxide into the atmosphere. This has raised concern because the CO2 is released immediately, while the carbon payback from biomass can take many years. In addition, the sustainability of biomass supply chain, such as imported wood pellet, is being questioned due to forestry practice and transportation emission. Although the CHP system is very efficient, it does not remove the carbon dioxide from the atmosphere. As Denmark is moving toward carbon negative climate target, biomass alone may not be enough. Therefore, the main problem at Everdorf is the continued release of CO2 and the need for an advanced solution to reduce or eliminate net emission. Okay, for my next slide is about the selected emerging technology. Okay, to address this problem, the selected emerging technology is bioenergy with carbon capture and storage, or we can also call BECC. BECC combine biomass energy production with carbon capture and permanent storage of CO2. Biomass absorb carbon dioxide while it grows, and BECC capture the same CO2. Again, after combustion. As a result, instead of being carbon neutral, the system becomes carbon negative, meaning it removes carbon dioxide from the atmosphere. BECC is suitable for Everdorf because it can be integrated into existing CHP infrastructure without reducing electricity or district heating supply. It also aligns well with Denmark's long-term climate and energy strategy. Okay, for my next slide is about the application of BECC. At the Everdorf Power Station, BECC will be applied by integrating carbon capture unit into the existing combustion and steam generation system. Carbon dioxide is captured from the flue gas produced during biomass combustion before it is released into the atmosphere. The captured CO2 is then compressed and transported to a permanent storage site, such as underground geological formation. This allows the plant to continue operating efficiently while significantly reduce its environmental impact. In this way, Ecuador can meet stricter emission requirements without major change to its core CHP operation. Okay, for my next slide, because BED is complex system, continuous monitoring and regular maintenance are very important. Real-time sensors are used to monitor CO2 concentration, flue gas composition, temperature, pressure, and flow rate. This data help operator maintain high capture efficiency and detect problem early. Routine maintenance is required for key components such as absorption column, solvent, compressor, and pipeline. Over time, solvent degrade and must be replaced to maintain performance. Predictive maintenance using digital monitoring can identify potential failure before they occur, reducing downtime and ensuring a stable supply of electricity and heat. Overall, effective monitoring and maintenance ensure that the BED system operates safely, reliable, and support Denmark's long-term climate goal. That's all from me. Thank you.
The most significant impact is the shift in our carbon status. While carbon neutral simply balance what we put in and take out, this project allows Ecuador to become carbon negative. By capturing carbon dioxide before it hits the atmosphere, we are effectively cleaning the environment, which is a key goal for Denmark's energy strategy. This also reinforces the sustainability of using biomass. We know there are concerns about supply chains and carbon payback times. However, by capturing emissions right at the source, we validate biomass as a truly long-term renewable solution. Critically, we achieve this without sacrificing performance. Our analysis shows that despite adding the capture technology, the plant maintains its high efficiency in generation, both steam and district heating. The energy output remains stable. Finally, the upgrade includes advanced real-time sensor and predictive maintenance tools. This not only prevents outage, but effectively future-proof the station against increasingly strict EU climate regulation. So, in this part, this diagram illustrates exactly how we integrate the new BECCS technology into the existing Ecuador facility. The most important thing to note here is that the core design of plant remains largely unchanged. The combination of biomass, steam generation, and the production of electricity and district heating all continue exactly as they did before. We choose this specific location because at this stage, the carbon dioxide levels in the flue gas are still very high, which allow us to capture it most efficiently. Once captured, that carbon dioxide is compressed and transported for permanent storage. By adding this modular unit without disrupting the main power generation, we are effectively transforming Ecuador from a carbon neutral facility into a carbon negative energy hub.